Hey guys, welcome to my chemistry lab. Today we will investigate the concept of mole ratio in chemical reactions. We want to study the mole ratio in a compound and mole ratio relationship in chemical reactions. So generally for a chemical reaction, the mole ratio of reactants and mole ratio of each reactant product are fixed and well defined. The chemical reactions, they follow the law of conservation of mass, law of constant proportions, and law of multiple proportions. Thus, the reactants and the products, they maintain a mole ratio relationship. So, there's still many chemical reactions occurring in certain conditions where the different mole ratios are encountered, even when the reactants are the same. So, with the varying molar ratio of reactants, different precipitates are formed. The mole ratio may be determined by examining the coefficients in front of the formulas in a balanced chemical equation. Before proceeding to our experiment, let's do the pre-lab concept. It is important to know about the limiting reagent in a chemical reaction. The limiting reagent in the chemical reaction is a reactant that is totally consumed when the chemical reaction is completed. The amount of product formed is limited by this reagent since the reaction cannot continue without it. So let us consider the chemical reaction. Lead nitrate plus 2 potassium iodide forms lead iodide plus 2 potassium nitrate. The molar ratio in this reaction for lead nitrate and potassium iodide is 1:2. So if number of moles of lead nitrate is less than half of number of moles of potassium iodide, then lead nitrate is the limiting reagent. Whereas if number of moles of potassium iodide is less than twice of moles of lead nitrate, then potassium iodide would be the limiting reagent. In this lab, we will observe the amount of precipitate and verify the concepts of molar ratio. Okay, so in our materials, we have the 0.1 molar solution of potassium iodide. We have the 0.1 molar solution of calcium nitrate. We have 0.1 molar solution of copper nitrate and our 0.1 solution of sodium oxalate. These are going to be our solutions. Now here we'll have our 96 well reaction plate, and here are our 2 toothpicks. Okay, let's start with our procedure. We'll be doing 2 chemical reactions. The first chemical reaction we'll do in the first row, and the second one in the second row. So first we'll investigate the reaction between the copper nitrate and potassium iodide, which will form the cupric iodide and potassium nitrate. So first we take the copper nitrate and we'll pour 1 drop into well A1, 2 drops into B1, 3 drops into C1, 4 drops into D1, and 5 drops into E1. Now similarly, we'll pour the potassium iodide in reverse order. So first 5 drops into A1, 4 drops into B1, 3 drops into C1, 2 drops into D1, and 1 drop into E1. Okay, so now we'll look at the second reaction between calcium nitrate and sodium oxalate. Let's put them together, and this will form the calcium oxalate and sodium nitrate. So first we'll take the calcium nitrate, and this time in row 2 We will first pour 1 drop of calcium nitrate, 1 drop into A2, 2 drops into B2, 3 drops into C2, 4 drops into D2, and finally 5 drops into E2. Okay, now that we have poured the calcium nitrate, now we'll similarly pour the sodium oxalate in reverse order. We'll pour the solution in reverse order. So 5 drops into A2, 4 drops in B2, 3 drops in C2, 2 drops in D2, and 1 drop in E2. So after the precipitate settled down, the observation is made for the well containing the maximum amount of precipitate, and it will be noted down in the tables. The reaction between copper nitrate and potassium iodide is recorded in table 2.1, and the reaction between calcium nitrate and sodium oxalate is recorded in table 2.2. From our experiment, in our first chemical reaction, we found maximum amount of precipitate in well B1 because it had the highest amount of brownish precipitate. So then for our second chemical reaction, we found the maximum amount of precipitate in well C2 here because it had the highest amount of milky precipitate. Okay, so to our results of our chemical reactions. First we look at the first reaction, and here we found that B1, the well with the most precipitate, had 2 drops of 0.1 molar solution of copper nitrate and 4 drops of 0.1 molar solution of potassium iodide, therefore having a mole ratio of 1:2 as marked in table 2.1. So it is verified that in this chemical reaction, the molar ratio of reactants cupric iodide and potassium iodide is 1:2. So the balancing chemical equation based on molar ratio of reactants is copper nitrate and potassium iodide form cupric iodide and potassium nitrate. We can also note that in well A1, cupric iodide is the limiting reagent, whereas in well C1, D1, and E1, the potassium iodide is the limiting reagent. So now to our second chemical reaction. C2, the well with most precipitate, had 3 drops of 0.1 molar solution of calcium nitrate and 3 drops of 0.1 molar solution of sodium oxalate, therefore having a molar ratio of 1:1 as we marked in table 2.2. So it is verified that in this chemical reaction, the molar ratio of reactants calcium nitrate and sodium oxalate is 1:1. So the balancing chemical equation based on the molar ratio of reactants is calcium nitrate and sodium oxalate form calcium oxalate and sodium nitrate. Here we know that in wells A2 and B2, calcium nitrate is the limiting reagent, whereas in wells D2 and E2, sodium oxalate is the limiting reagent. So in conclusion, we found the molar ratio of reactants in our experiment and then determined the balanced equation. Besides that, we also determined the limiting reagent. The real-world connection of this investigation is that generally chemical reactions follow law of conservation of mass and law of constant proportions, which ensures the reactants and products to maintain a mole ratio relationship.